we have to derive this. dA by A is equal to minus of 1 minus m square du by u. So I'm taking some nozzle. Okay, you can take any convergent, divergent, any nozzle you can take it. Just for the representation, I'm taking divergent. First I'm applying continuity equation. Okay, rho 1 u1 a1 is equal to rho 2 u2 a2. So the general form is rho ua is equal to constant. So what I need is the du by u. Okay, so I'm going to differentiate this equation with respect to u. Okay, so here I'm differentiating, but you see the nozzle, and this semester we are dealing with compressible flow. That means density also will vary, velocity also will vary. Here area also it is vary. It may increase or it may decrease. Everything is variable here. Okay, if it is only two parameter, then we can apply the differentiation of uv formula. If you differentiate, you will get u dv plus v du, right? That formula you can apply. But here I have three variables. So how they are simplifying means they are grouping two variable as a one, then second variable as the second one. Like that they are grouping and making it as a two variables. Is it clear? You can take any combination, rho a, u a, any combination you can take. Just they are grouping so that they can apply this differentiation of uv formula. Now if you take u into dv plus v into du, is it clear?
Yes.
Okay, so this is u, this is v, like that they are taking. So u into dv plus v into du. Okay, now this term is over. Okay, rho u dA by u, this is fine. Now this term if you take again, both are variable. Okay, d by du of rho u, both are variable. Again another one uv formula you have to apply. Okay, so u into dv plus v into du, like that another one differentiation they are doing. So du get cancelled, so remaining you will get only rho plus u. Then instead of this d rho by du, because at the final term there is no density etc. So to convert that they are writing into two terms, that is d rho by dp into dp by du. Okay, d rho by du they are writing as d rho by dp into dp by du, like that they are writing. Why they want to write in this manner means we know this dp by du or dp by d rho, it is a square. In the speed of sound derivation we studied, a square is equal to dp by d rho. So instead of this I can write 1 by a square. Okay, then this dp by du I can use the Euler equation, dp is equal to minus rho u du. So in that if you rearrange I will get dp by du is minus rho u. So instead of that I can substitute minus rho u. Okay, so instead of this d rho by du I can substitute minus rho u a square. Is that clear?
Yes, sir.
Okay, so instead they have taken 1 by a square, and instead of this it is minus rho u, and u is already there, they have taken. Now you simplify, you will get rho minus rho u square by a square, and this u square by a square is m square. Okay, then you take rho outside, so rho a 1 minus m square. That's what they mentioned here. Is it clear?
Yes.
Only this term we are writing like this. Okay, now we can substitute this here. Okay, in this equation, so d by du of rho u a is equal to rho u dA by u, rho u dA by u plus this one straight away they are taking instead of this term. Okay, so this equation, so instead of this term they are taking this. Then you can divide this equation by rho, or you can take the rho outside and take it to the right hand side and then rearrange. Finally you'll get this equation. Okay, normal rearrangement. Then using this equation, so they are finding how subsonic supersonic flow changes in the convergent divergent duct. Okay, how subsonic supersonic flow changes using the convergent divergent. First we will see the subsonic. For example, I am taking Mach number of 0.2 subsonic. Okay, so here if you substitute 0.2, then 0.2 square will be 0.04, then 1 minus 0.04 means 0.96. Okay, so instead of this I will get 0.96. So what I will get, it is dA by A is equal to minus 0.96 du by u, right? So that they are taking here. So for less than 1, so dA by A is equal to minus some term into du by u. So this shows both behave in the opposite manner. That is, if area increases, then velocity will decrease. This negative sign shows that. Okay, area increases means velocity will decrease. So it behaves in the inverse opposite manner. Or if area decreases, velocity will increase. That's why in all the subsonic aircraft, if you see the exit of the engine, you can find this convergent type of nozzle. Even in our subsonic wind tunnel, in any aircraft, subsonic aircraft, if you see, it will have a convergent nozzle because that converts subsonic flow to high subsonic. Okay, so in the subsonic region, if you want to increase the velocity, then area has to be reduced. Is that clear?
Yes, sir.
Okay. Divergent means it will decelerate the flow. Like in the wind tunnel, we are using in the exit of the wind tunnel after the section. Okay, diffuser. Then supersonic Mach number, same equation. Assume I am taking Mach number of 2. Okay, then in that case it will be 2 power 2 4. Then 1 minus 4 is minus 3. So instead of this I am getting minus 3. Here on minus 3 is there. Totally I will get plus 3 du by u. Okay, so for supersonic I am getting positive value. dA by A is equal to some positive numbers in du by u. So here area increases, velocity also increases. Okay, both are behaving in the same fashion. That's why in the supersonic duct and all, if you see, we will use divergent as the nozzle. Even in the what is it? Hypersonic vehicle, I have shown, right? Divergent duct. So if you want to accelerate the supersonic flow to further, you know what is the engine we are using here for hypersonic vehicle? Do you remember? Okay. So here flow is supersonic, and to further accelerate this, we are using the divergent duct. Okay. So for supersonic means nozzle should be a divergent. From low subsonic to high subsonic means it should be a convergent, like all the commercial aircraft. From subsonic to supersonic means then the CD nozzle will come into the play. Okay. So area Mach number means, so we are relating A star and A. Okay, A star, you know, it is correspond to the throat section. Okay, and this A can be the subsonic inlet or supersonic exit. Okay, here in this equation 2A is involved, only simply A, another one is A star. A star is corresponding to the throat, and this A is, it can be a subsonic inlet or supersonic inlet. That means if you take this CD nozzle, so this A by A star equation, either you can apply to this section, that is throat to exit supersonic Mach number, or you can apply here also in the inlet, throat to inlet. This can be a subsonic. Is that clear? Both sides it will be applicable.
Yes, sir.
Okay, so A star to supersonic AE, otherwise A star to subsonic this AE. For both this is the only formula. So from this formula you will get two Mach numbers. One is subsonic Mach number, another one is supersonic Mach number. So depends upon the duct you are solving, you should choose it. This is already discussed. Okay, so to relate this A star, again they are using this continuity equation. Okay, anywhere we can take it. Okay, assume I'm taking this is station 1, this is my station 2. Okay, I'm taking only this duct now. So rho star U star A star in the throat is equal to rho U A in the exit. You know here M is equal to 1, then V is equal to A, okay, and we are denoting all the property as star. So here V star which is equal to A star. So instead of this U star I can write A star because V is equal to A. Okay, then what I need is the A by A star. Okay, then from this equation I have A and A star. So take this A star here, remaining term here, you will get A by A star is equal to rho star A star divided by rho U. Is that clear?
Yes, sir.
Okay. Again in the final equation, what I have is only the Mach number, no other parameters. So I don't want this rho star, rho U, A star and all. So to simplify this, I'm just multiplying by rho naught by rho naught. Okay, this is the original equation. I just rearrange the continuity equation. Then with that I'm multiplying rho naught by rho naught. Now how I'm going to write it is rho star by rho naught. Okay, then rho naught by rho, second term, remaining is A star by U. Is it clear?
Yes, sir.
Okay. As the CD nozzle is, always we are designing to produce the optimized flow, that is which converts subsonic to sonic, then sonic to supersonic without any shocks, without any losses. The flow will be isentropic. Okay, that is called design operating condition, otherwise optimized condition. So the flow is isentropic. We know these relations. Rho star by rho naught by rho, everything already derived in the isentropic relation. So rho star by rho naught is 2 divided by gamma plus 1 power 1 divided by gamma minus 1. Then rho naught by rho is 1 plus gamma minus 1 by 2 m square 1 divided by gamma minus 1. Okay. These two straight away we are taking from the isentropic relation. At last we have A star by U. Okay. For that also we derived it. That is relation between characteristics Mach number and local Mach number. Okay. So M star means it is U by A star. Okay, but the derivation is derived like M star square in terms of M square. So here also we are adding square. Okay. U by A star we have, which is M star. But the derivation we derived it for M star square in terms of M square. So I'm just adding square here also so that I can take this term in terms of Mach number. Is that clear?
Yes, sir.
Okay. So this I want to take it as square. Then what I have to do? I have to take square everywhere. Okay. So that instead of this I can write 1 by M square, 1 by M star square. Okay. So I am taking square everywhere. So here also if you put square, then what will happen? Here you will get 2, right? Here if you put square, here also you will get 2. Is that correct?
Yes, sir.
Okay. Now we have to substitute these 3 terms. 2 divided by gamma plus 1, 2 divided by power 2 divided by gamma minus 1. Then this term, then this term, that is here 1 by M star square. Just inverse I have substituted. Then I have to simplify this term. So this term, how I can write it means, so 1 plus gamma minus 1 by 2 M square power 1 into 2 divided by gamma plus 1, okay, into 1 by M square. Is that correct?
Yes, sir.
Okay. So here 2 divided by gamma plus 1 power 2 divided by gamma minus 1, and here 1. Now I can compare these two terms. I can write it like this. That is power alone I can simplify. 2 divided by gamma minus 1 plus 1. And if you rewrite, you will get 2 plus gamma minus 1 divided by gamma minus 1. So this will get cancelled. So you will get gamma plus 1 divided by gamma minus 1. Okay. Is it clear?
Yes, sir.
similarly, here I have 2 divided by gamma minus 1, and this time is 1. Again, x power n into x power m, it is x power m plus 1. Same term you will get it. Okay, gamma plus 1 divided by gamma minus 1. Okay, so instead of this I can write gamma plus 1 divided by gamma minus 1. Instead of this it is gamma plus 1 divided by gamma minus 1. Only this 1 by m square is outside. Okay, and you remember that isentropic relation table, right? Once you know the m, I think you can find m star, right? First,
Yes, sir.
then what other thing you can find it from isentropic table?
So P by P naught, T by T naught.
P by P naught, T by T naught. As I said, AE by S star also can be found it, right?
Yes,
Yes,
sir.
sir.
Okay, so in this problem, so they are given, consider a optimized CD nozzle, and settling chamber pressure is given, and CD nozzle exit pressure is given. You have to find what is the AE by S star ratio. Okay, for the optimized CD nozzle, settling chamber pressure is given, exit pressure is given. You have to find AE by S star. How will you find?
So we find the corresponding ratio, Mach number for P by P naught given,
Okay.
and then we can compare that to
Okay,
AE and
so
S star.
isentropic means P naught will be constant. Even though it is a settling chamber pressure, P naught 1 is given, it will be same throughout the duct. So P naught E also will be same. Okay, so we can take PE by P naught E. That ratio you can find it. Then using this isentropic table, I can find the corresponding Mach number, also corresponding A by A star. So is isentropic, T naught P naught is constant. So in the settling chamber, also in the exit, wherever you find P naught is constant. So first they are finding P by P naught or P naught by P. Then from the isentropic table, you can find corresponding Mach number, also A by S star.